We're going to switch it up. Thank you, Jason. Thank you, Zane. We're going to talk about the Kong API Gateway. My name is Chris McHugh, and I work at Shokunin Consulting. And some of these slides may look familiar. So we talked earlier, a problem well stated is half solved. So let's talk about the problems, the solution, the technical solution, because they're not always the same, the caveats and the improvements. First problem, we need to get a handle on the API consumers. This has been a problem at many of my clients. Who is accessing my API? What are they doing? So we take this, we write this great API, we stick it out in the world, and everybody starts using it in weird and different ways. So we need to get a handle on who's using it, right? We need to stop bad consumers from DOSing our API. You know, anything that's out in the wild is going to get weird stuff coming in. We just talked about the different kinds of data coming in. You don't always have quality control on what's coming in. So you need to be able to handle that outside of your API. We always need better visibility into everything. Right? One of the key tenets of pretty much all my clients is we want to know what's going on. Right? We want to see what's happening so we can react with data as opposed to kind of just feeling and make good decisions based on the data we get in. And we need real-time information. Like tomorrow is probably not going to help during an outage right now. So the solution was to add a proxy in front of our APIs. And the technical solution was to use Kong. So Kong had a couple of features that we really liked. It has different methods of authentication, right? So one of the things is if you don't authenticate your API, you can't tell who's coming in. And you also need a little bit of a barrier for entry so you can get an idea of who is accessing your data. It handles all of these different authentication mechanisms, so that was very nice. There's some security features like IP blacklist, bot detection, dynamic SSL, and real-time ACLs. Some of the control, rate limiting. Rate limiting was a huge feature that we wanted, right? This is basically you have these large queries on your database, and you have somebody who writes a script that hits your API every minute, doing this extremely large query, and they pile up and take out your database, and your pager goes off, which no one really likes. There is response rate limiting, where you would add a header to your application, and then rate limiting is based off of that. So any rate limiting coming in, right, is based on the method of authentication you use, but the response rate limiting is based on your application. So you could say, anybody who makes this expensive query, I send back an extra header for that expensive query, and now you can rate limit on that expensive query. The downside to response rate limiting is it requires changes in the application, and that's not always possible. And request size limiting. So that if somebody's sending you data, for example, to process, so they're sending you 5,000 leads all at once, you might say, no, we only take it in batches of 100. So we can limit the size of the data coming in that we have to process, which is often a common problem with an API. There are also, you can do transforms on the request. So you could maybe rewrite the host header, add an extra header, add a correlation ID. And this is something that we've done in a lot of places where you need an ID to go through your whole stack so that you can trace back what's going on. So for example, one customer, we modified the ORM to include this correlation ID as a comment in a database query. So now you have these slow-running queries. You can look at this correlation ID, track it back through your Elk stack or, God forbid, Splunk, if you're crazy, and figure out exactly which code path is generating this nasty ORM query so that you can kind of troubleshoot that way. Visibility features, right? Logs over several different mechanisms, syslog, statsd, Datadog. Datadog is basically just hitting statsd on the local host, so it's not super impressive. Runscope and Galileo, neither of which I've used. Does anybody use Runscope or Galileo? Just added it there because somebody might use it. The main considerations that we have for choosing Kong were one, that it's open source, right? I don't want to spend a lot of time in a Splunk or something forum to try and figure out some software or wait for features that we need right now, right? It's built on trusted technology. It's built on Nginx, OpenResty, and Lua. These things are all run in production in thousands of different places. It's easy to extend. You can write a custom extension in maybe a day if that's the only thing you're doing. You can actually sit down. They have a really good development environment. You can learn it, and you can customize what you need. There's no licensing costs, right? If you're using a third-party API service, you're going to be paying through the nose on licensing costs, which is a big upfront cost that you don't want to pay. It clusters well, it caches, and it's easy to automate so that we can deploy it using Ansible or Puppet or Chef or anything really quickly, and we can replace them really fast on AWS. So the basic Kong architecture is you have your authentications, your plugins, any custom plugins that you want to write, rate limiting, and logging. So all of these things are together so that you have the complete package of managing your API. Internally, the API client basically hits Nginx, right? Nginx is compiled with Lua enabled. And has anybody ever heard of OpenResty before? It's a shared set of Lua modules for Nginx that allows you to do all kinds of interesting things like user authentication or caching in Redis. And so a lot of this is already built in, right? And then the custom Lua in the back that is all of the bits for Kong. And then it makes the call to your upstream server. In the case of a cluster, this is actually Postgres, not MySQL. I didn't have a good Postgres one. But you have all of your Kong nodes, and they talk via Surf. Surf is the protocol that is based off of Consul. So it does clustering, it does gossip. So if one node goes down, the other ones gossip amongst them to figure out what's going on. It also includes network tomography, which is really nice. So you can do a query, say, find me the closest Kong node in terms of round trip times. And whenever anything changes, it will notify the other nodes in the cluster that something has changed and jobs can be run. So if you have your own piece of software that you need to cluster tomorrow, you download the Kong binary and you can basically listen for different events. And so it's really useful for just clustering anything, right? And then also we have, for rate limiting counts, we use Redis to keep track of who's making calls to what. All right, let's get started. So I have a testing environment, which is configured with Terraform. It's 3 Docker containers. It's a Postgres container, a Kong test container, and a Redis container. And it downloads those and sets them all up for you. The longest part of this is downloading the actual containers. It's really quick after that. So we're going to set up an example API. So this is all done via the HTTP API, so you just do everything in curl. There are a couple of GUI front ends. They're just not quite there yet. And I like these curl commands because you can automate them very easily. So basically you say post to the localhost API's endpoint. 8001 is the administrative interface, and 8000 is the HTTP interface that does the, you can obviously set them differently, or you can set up SSL for encrypted, right? The name of the API, so that's your key example API. The hosts, this is actually an array. You can have several hosts in here. So it will examine the host header coming in, and based off of that, it will route upstream to your upstream URL. And this can be HTTP or HTTPS. It doesn't really matter. So it's just saying anything that comes in with the host header example.com, go ahead and ship off to http-bin.org, which is just a service that just listens and replies. So it's a good test. There's also mockbin. So when you're testing, you can use these to figure out your Kong configurations. Obviously, after we perform an action, we want to test it to make sure it actually works. So we run a curl. Notice we set the host header, right? And you'll see that it comes back with a 200 OK. And now we get these 3 extra headers added in. So we've got via, so we know that it came through Kong. We have the Kong upstream latency. And that is the time in milliseconds that it takes for your Kong instance to connect upstream, fetch the data back. And your Kong proxy latency, that's the amount of time that it spent within Kong before it did anything. This is generally really fast in production. I don't see this go above 5 milliseconds usually. So for these larger API calls, it's basically insignificant as a percentage. So now that we have our API set up, we want to authenticate, require authentication. So we basically say APIs, give the name of the API and plugins. This is how you enable any plugins, right? So we're going to enable the key auth plugin and data config. So you have these config variables that you can set for each plugin. Config.hide credentials is false. By default, it's true, and that just means that if you hide the credentials from the upstream server, say, for example, it's an API you don't control, and you don't want to send the login information as headers to them, you can just leave that as true. Next, we set up a consumer, and a consumer, you want to think of that more as a user, right, or an organization, somebody who is using your API. So we're going to create a consumer. There's a consumer's endpoint, and we set the username and a custom ID. And this custom ID can be anything you want that will match with maybe some database or some CRM that you have in the background so that you can tie these things back together. Once we have a consumer, we can create several different keys for that consumer. Right? So we're going to basically consumer key auth, just pipe it to JQ so it looks nice, and we say, okay, we created this new API token, and this is our API key back that we get back. So now you would give that API client to your consumers of your API. So again, we'll test it again. So we're going to curl it, and we curl it, and it's going to return a 401 unauthorized, right? So because we didn't send the API key. Now once we turn this on, you need an API key to access the API. And it tells you nicely, you can have the API in the header or in the query strings. So now we can test it with a key. So we set the header API key to the key that we just got. And we do our curl again. You see the header is set here, and we get our 200 back. So now that we've authenticated, we can go through the API. If you don't set the upstream to not viewable, it will send these headers to your upstream API. So you know the consumer ID, you have the custom ID that we set, and the username that we set. So for example, some applications will look to make sure that this is set, or it will take some actions off these headers. And you can also add other extra headers you need to so that you can go ahead and... The other nice thing is it sets X real IP and the X forwarded proto, which you can use upstream to make different configurations in your application. So again, we have the API so that we can get information about the consumer. We can see when it was created, all of this information. And note that this ID is the ID of the consumer. It's a UUID for every consumer. Right? And that's stored in other places that I'll show you within Kong. Say the consumer stops paying us on time. And we decide that we're going to revoke access to our API. Right? We can actually just, using a delete and curl, and just delete the whole customer. And you'll see that now we query the customers again, and that customer is gone. So they no longer have access to the API. And obviously, we retest again with their API token, and now it gives a 403. Right? The token is set, but it's incorrect. So 401 if you don't have a token, 403 if you have an incorrect token. So the next main feature that we wanted was rate limiting. So again, the two ways to rate limit and response rate limiting, where you send back custom headers that will rate limit based on those factors. We're going to go straight rate limiting for the start, right? We just make a post call to the API. We set the rate limiting plugin on. So config.second. So that means you get 1 call a second. Config.minute, you get 10 calls a minute. There's hour, day, month, and year. I've only set up to month. I've never set up a year, just because I don't think that far ahead. Config limit by. So you can configure exactly what you're limiting by, and we're going to use the consumer ID. So we're going to limit by consumer ID. And the config policy, there are 3 different config policies. The first is localhost, which if you only have one, kind of makes sense. It just keeps it in memory. There's cluster, where it kind of talks amongst the cluster. And I chose Redis because that gives me kind of a lot of flexibility using other tools. So it's going to store to a Redis instance, and the config host is Redis and the Redis port that we're going to use. So this is in that Terraform cluster that you can download and play with, so it'll automatically configure all of this for you. Warning. If the limit by can't be determined, it falls back to the IP address. Where this is going to bite you is if you have an HA proxy in front of your Kong and you set it up incorrectly, it's going to limit by the IP address, which is your HA proxy where all the traffic is coming from, and you're going to spend half your day banging your head against the wall trying to figure out why it's so slow. So just as a warning, falls back to the IP address if you don't set anything. That might be useful for some public APIs, but again, just be careful because that definitely did bite me. So now we're going to go ahead and test our rate limiting setup. We cat our temp key, our API key, we go ahead here, and now we get a bunch of extra headers. We get X rate limit second, 1. So that means you get 1 call a second. Remaining per second. So it tells you how many calls you have remaining in the headers, which is really useful for troubleshooting, right? It tells you the minute and the minute late and how much you have left for each minute. If you set up hour, day, month, and year, it will give you all that information as well. So this makes it really easy to troubleshoot when you're having a problem. Right? So we run it in a loop several times to test it to see what happens when we hit our limit. And when we hit our limit, it sends back a 429, which I had to look up. It just means that you've hit your limit, too many requests. Right? So it's a pretty standard to send back a 429 from an API. And you'll see that you hit your remaining limits per second is now 0. So you know which limit you hit. You know you can back off and maybe go for a minute. So what actually gets stored in Redis? Because you got to play around with Redis when you have it in production. So you'll notice that these are the keys. So we get rate limit, the API ID, the consumer ID, and this is the time in milliseconds. And then you have hour, year, month, day. And so these all are set every time a call is made. So every time you do make a call, you're calling out to Redis. Redis normally returns in microseconds, so it doesn't add much latency to anything. So you don't really have to worry about that there. And you can see what's actually inside these Redis keys. This number gets decremented, right? And if you look at the TTL, they're set. So the second key has a TTL of 1 second. The minute key has a TTL of 1 minute. So these keys actually get cleaned up for you as Redis is running in production. You will note that in a heavily used Redis, if the TTL expires, it doesn't actually delete the key. It just marks it as available for memory reclamation later in the future. So it doesn't actually do the garbage collection. It just marks it as a negative number. And that means that's a slot that Redis can go through and reap if it runs out of memory. So that's confusing to a lot of people. Why am I getting a negative number for TTL? Okay, last, visibility. Who's doing what on my API? All right, this is a question you constantly have to answer. So one of the nice Kong features is you can set up a custom Nginx configuration. So say, for example, your customers want to use two-way SSL certs, right? So they need an SSL cert to authenticate against your API. That's a standard Nginx setup. You can basically modify your Nginx configuration so that it happens right away. One of my first changes to every single Nginx box is I changed the logging format to look like JSON. And the reason I do that is it goes nicely into Elk, right? So you get good fields. You don't have to parse any logs. And so you'll see that this generates a JSON-y looking string, right? And we add in a bunch of fields like the consumer username. So now that's in your logs. You have a log for that, right? You have the API key, which you probably shouldn't log, but I just kind of showed it as an example. Protocol, you have the time in milliseconds it took for your request to complete. So it's really nice to have all of this data in one place, and then it flows easily into your Logstash or your centralized logging system. And it gives you all this information here that you can later use. You say, oh, the request query is get username Reiko McGue, and it took, took 2 minutes. Sorry, 2.053 2,053 milliseconds. You notice that the proxy latency is 1, and you'll notice that the total duration is, you add those two together. So one of the things that you need to kind of keep an eye on is this proxy latency to get an idea of how overworked your Kong is. And again, you can add another one to the cluster, super easy. The Kong instances will gossip amongst themselves, so once it connects to the database, it registers as someone who might be available for gossip, and then it automatically joins the cluster. So you don't have to do any seeding or anything like that. As long as it can find the database, you're good to go. So you put them in an auto-scaling group, add as many as you want. So we use the statsd plugin. And we basically say, hey, this host, this port, start sending your statsd information. There's Datadog as well, but Datadog is just using statsd over the Datadog input. I haven't tried the others. This is an example of a dashboard. For the example API, you can see these are the total requests coming in. You have latency and upstream latency, so if you start to see a gap in this graph, you know that you have your Kong slowing down. You need to take a look at it and figure out what's going on. And then you have your count by HTTP code. So you have a good breakdown of what's going on per API. So you get the stats per API. The API name is what is the stat that's going out. So if you can add multiple APIs to a single Kong instance, right? And again, it just looks at that host header and then does the determination from there. The required no silver bullet slide. This is now extra moving parts in your infrastructure. Which again, pluses and minuses. I'd say on the whole this is a plus because it adds a lot of visibility, it adds control. You can spin up several of these Kong instances outside to strip out any requests that come in before they hit your API and kind of protect yourself that way. Learning Lua is a good idea. Lua is a very small language. It's embedded in Redis, it's embedded in Nginx, and it's a lot of game engines use it because it's really small and really quick. It doesn't do a lot. You have to download Lua rocks, which are like Ruby gems or Python pips, to do a lot of things that you'd think would be normal, but because it's such a small language. But it is kind of fun to play with, and there's some good ideas in it. It starts counting from 1, not 0. That's going to throw you initially. But again, like I said, learning Lua, learning to write a plugin and everything will take you about a day. And the code is well documented and pretty easy to understand. And the documentation guides are good. So it does add extra latency. So if your API call is 2 milliseconds and you're adding a millisecond, obviously that's probably not what you want to do. But for longer API calls, longer, more expensive API calls, it's definitely worth the effort. And there are GUIs available, but like I said, they don't work great. So I wrote a kind of Django plugin so that we can access the configuration from our actual administration portal. So it's not too hard to write against the API. I did want to write an Elixir, but they don't use that there. Things that I would do better in the future. I want to write a custom plugin for kind of better visibility. So depending on maybe the path, like the first 3 segments of the path, so I know which controller it's hitting, and I can collect more detailed stats. Like the 201s and 200s are nice, but if I can measure maybe checkouts or some kind of business metric, I think that would be a little better kind of long run to give people, have a nice dashboard that shows all of that. Better monitoring, checking that Kong latency, making sure that doesn't get too big, monitoring the DBs and the Redis usage. And I would like to move more things to the response rate limiting because that allows developers a little more flexibility on kind of what they're rate limiting and how they want to handle their own rate limiting. And you don't have to do as much static configuration. For example, you might have different tiers of customers. Customer A is in the super high expensive tier, and so therefore their rate limiting numbers might be different than the free tier. So it can kind of go that way as well. Thanks to the guys that wrote it. Thanks to Zillow, Zane, and Jason. Appreciate it. Any questions? Yeah. How old is it? I don't know. It's been around for a little while, but I know that OpenResty's been around for years because I checked it out a while back. So it's really kind of just on top of OpenResty. Yeah, I don't know, but it's pretty solid. Just started running in production for one customer, and I've seen it run elsewhere too. Yeah. Yeah. You can set up authentication. So you can use a Nginx two-way cert, basic auth. You can basically set it up kind of any way you want. I just have it limited mostly to localhost, and no one else can log in. But I try to do as much of it through the configuration management as I can, not by hand. So try to eliminate that problem.
Roll in with Postgres used for in Redis or vice versa, so that you're eliminating a part?
So basically the configurations are stored in Postgres and it's not constantly hitting for the configuration. So part of this, that surf thing is when you change the configuration, it notifies the other nodes to reread the configuration, which it keeps in memory. So there's not a lot of call back and forth to the database. It's actually only used when you change the configuration. So I have it as a very small RDS instance. Pretty much all the important data I store in Redis. So one of the custom plugins I wrote takes the API key that is not handled by Kong, it's handled by the actual application, does a call upstream to the API to get the organization that these people are a member of, then stores the username to organization map in Redis, and then uses that for rate limiting. So you can rate limit on the organization as opposed to the individual user. And like I said, that plugin took 2 days with various other things happening at the same time to write. So it's pretty flexible, and the Redis lookups are super fast. So. Cool. Yeah. Oh, so it's just a proxy in front of your regular API, right? So there's a couple ways you could handle it. You could modify you could roll out a new ASG or something, right? And then maybe change the upstream to that new one. You can just modify the config in place, or this is often in front of another load balancer. Then you have all your apps behind there. So you could use console DNS lookups because they have a DNS resolver. You could set to a different DNS resolver, and it'll do the upstream round robin for you. But this generally is in front of like HA proxy or Trafic or another kind of load balancer. Never in front of an ELB. Never. Any other questions? Sorry, that dumped really fast. So we will have the slides online.